So we're going to look at the probability of compound events. So two events are not compound if they can't happen at the same time. So if they can't happen at the same time, then they're just mutually exclusive. Can occur at the same time, but if the events we're trying to find the probability of could happen at the same time, and I'm hoping that when we do some examples this makes more sense, then they're compounding on one another. There's an overlap there. So there's two ways to find the probability of two events happening, A or B. If there's an overlap here, the probability of A or B is A plus B, both events added together, but we need to subtract that time or those times where they are the same thing. We want to only include A or B. We don't want the probability of A and B. So we exclude that from the probability. But if they are mutually exclusive, it simply is just probability of A and probability of B. So let's look at an example. It says a card is randomly selected from a standard deck. What is the probability that the card is a heart or a face? So probability of a heart or face card. So I'm going to pull up my deck of cards. Here, let me find it. So there's 52 total cards in a deck. The hearts, each suit, consists of 13 cards. So there's 13 hearts in a single deck. And there's the jack, queens, and kings, which are face cards. So there's a total of 12 face cards and 13 hearts. So if we're looking at this, where is the overlap? So I sort of boxed the hearts and the face cards. So which three cards are hearts and faces? These three here. There's three of them. So we don't want to include the probability of those. We only want the probability of the ones that are one or the other. So we're going to say 13 hearts and 12 face cards. So 13 out of the 52 are hearts, plus 12 out of the 52 are face cards. But because these cards can be the same thing at the same time, this is where we need to subtract those three cards that are both. So for fractions, we keep that denominator of 52 and say, what is 13 plus 12 minus 3? So 15, or 13 plus 12 is 25, minus 3 is 22 out of 52. So this is going to be 11 out of 26, or you guys could divide and get 42.3%. Fraction or percent, either one is fine as your answer. But if you're getting a decimal, you need to convert that to a percent. So it would be 0.423, but that's 42.3%. So when you're finding the probability of one or the other, add those two probabilities up. But if there is a chance that they occur at the same time, you need to subtract that from those two sums. So for number 2, in a survey of pet owners, so 103 had dogs, 88 had cats, 25 had birds, and 18 owned reptiles. So it's telling us in A that nobody owned a cat and a bird. So there was no both here. There was no overlap. So it's saying, what would the probability then be of someone owning a cat or a bird? So probability of cat or bird is going to equal 88 cat owners out of the 200 plus 25 bird owners out of the 200. So we don't need to just magically know if there's people that own both a cat and a bird. There could be, but in this survey, there was no one that owned both. So there's nothing to subtract here in the overlap because no two owners are going to own both at the same time. So 88 plus 25 gives you guys 113 out of 200, which would be 56.5%. So again, if you like fractions, keep fractions. If you like percentages, use percentages. It doesn't really matter to me. Okay, so then for B it says, okay, well, 52 of the respondents in the survey did own a cat and a dog. I personally have a cat and a dog. So if 52 owned both, that's the overlap there. So what's the probability that a respondent owned just a cat or just a dog? So for this one, we're going to say, okay, for a cat or a dog, we know that 88 owned cats, 103 owned dogs, but it just told us that 52 people had both of them. So we don't want to include the ones that have this and that. We want just the people that have one or the other. So we need to subtract those 52 people. So 88 plus 103 minus 52 is 139 out of 200, which is 69.5%. So if there's overlap, subtract it. If there is no overlap, it's just A plus B, or first event plus second event. So C says of the respondents, 119 did own a cat or a dog or a reptile. So it's saying this probability is 119 out of 200 people that owned a dog or a reptile. So what's the probability that they owned a dog and a reptile? So we're trying to find the overlap here. So we know, again, how many people had a dog? 103. How many people owned a reptile? 18. So those are ones that had one or the other. How many people had both? So how many out of that 200 had both a dog and a reptile? Well, 103 plus 18 is 121. So 121 minus what gets us to 119. That means that there must have been 2 out of 200. So 2 out of 200 simplifies to 1 over 100, so 1%, or 2 out of 100 people, or 2 out of 200 people. So pay attention to the wording. Just pay attention. Is it asking you for, is it giving you information of this and that, or is it giving you information of this or that? So just be paying attention to the wording. But when you're finding the compound probability of two events, one or the other, we add them together. We just have to be conscious of if there's any overlap where we would have to subtract, because we don't want the probability of when they are both, just one or the other.